Good morning, everyone. My name is Byron Hood, and I'm an engineering manager at Facebook. I joined the Android infrastructure team at Facebook to work on hard problems that affect people all around the world at massive scale. And two of the problems that we're going to talk about today are improving app upgrade rates and reducing APK size. So what does the app upgrade challenge look like? Who here has most of their apps up to date? Yeah, that's most of us, right? That's not a surprise. Developed countries tend not to be much of a problem here. This varies from app to app, of course, but for the most part, people have automatic upgrades enabled, and they have access to Wi-Fi and lots of extra data to spare. On the other end of the chart, many users in emerging markets might be out of date. If you launch a new feature or a bug fix, it could take months or maybe even years for that to reach those people. Again, this varies from app to app, and I encourage you to run your own numbers to see how many of your users might be out of date. At a deeper level, in countries like India, we might expect to see that upgrades are affected at a regional level. Some areas are more up to date than others, and so I encourage you to try slicing your data that way as well. Let's talk a little bit more about the release cycle. Let's say you ship a new feature. If you run an A/B test using feature flags, and I really hope you are, after a few weeks, your users will automatically upgrade. And after a few more weeks, once the test is statistically significant one way or another, you'll be able to make a decision. But who gets left out? People who didn't upgrade your app. And people in emerging markets often are the ones who didn't upgrade their apps fast enough. And so they get left out of the product decisions. You could be making the app worse for them, and you'd never know. Users are missing out. They don't get performance and stability enhancements. They don't get new features, new experiences. They don't get the security enhancements that we have to make every now and then. And most of all, they don't get product decisions. We care a lot about all of our users. So what can we do to better serve the people who don't upgrade frequently? Supporting old versions has always been a problem for developers. There are tough trade-offs, like supporting old clients. I'm sure all of you have seen code like this at some point or another. And let's be real, this is the easy version. Once you have 120 different versions you're supporting, it looks a lot worse than that. When you're trying to modernize your code, app upgrades just slow you down. So most developers don't get a chance to focus on this. And that's too bad for people in emerging markets and the people who don't upgrade their apps fast enough. So what makes upgrading in emerging markets hard? Here in New York, a lot of us have high-end phones. We have strong LTE networks, and often we get access to Wi-Fi, like this convention. We tend to be early adopters because we can't wait to get the latest and greatest features. But what about emerging markets? Again, this varies, but users may have less to work with. They may be on lower-end phones or lower-end networks. They might be constrained by disk space or the unavailability of data. Data might be expensive, and so they might have to trade off between sending a video to their family or downloading the latest version of your app. There might also be a lack of technical awareness on how exactly to go upgrading your app. So here's what we can do as developers to stay up to date, help our users stay up to date. We know app upgrades is an important problem. We'll talk about awareness, communicating value, light interfaces, deprecation, upgrade pitfalls, and upgrade rates. So let's start with awareness. The first and the most important thing is getting people to know that an upgrade is available. So find places to let them know. In-app promotions. Some of the things you can do. You can have an about screen in your app. You can add clear prompts in different places. You can put it in navigation menus. And push notifications are also a good way to reach users, but don't overdo it. Same goes for full screen prompts. If you have a scrolling feed, you can add an upgrade prompt somewhere in the feed, maybe while the user is scrolling, or maybe at the top of the feed, or at the bottom of the feed. Once you have your users aware, the next thing that you have to do is communicate the value to them of upgrading their app. Try and be a little bit more creative than new app good, old app bad. Given how hard it is to upgrade users in emerging markets, be thoughtful. Often when you prompt them, they might not upgrade immediately. So what can you do to keep them engaged? Make it worth the investment for them. Be thoughtful about the frequency with which you prompt users to upgrade. How many versions into the past can you support? Maybe every 2 months, every 3 months, every month. That's a decision you have to make for yourself. Try to make the upgrade fun. Make sure people are rewarded for it. Because remember, in 1, 2, 3, or 6 months from now, you're going to be asking them to do the same thing again. Another strong motivator to consider here is the fear of missing out. Oftentimes, people want the latest features. Maybe they're just not aware of them. So encourage users to try out the latest things and teach them what they might be missing. It's important to invest in light interfaces as well. Sometimes, no matter how hard you try to encourage people to upgrade, they can't, or they won't. Maybe it takes too much disk space. Maybe the data costs are too high. But light interfaces and light versions, specifically versions that don't require frequent updates, can be a great way to still reach those people with your latest features. Treat your light apps and light versions as a primary interface, not a secondary interface. For some users, this matters as much or more as a full-sized app. A light interface is easier to download and easier to upgrade because it costs less data. And on a spotty network, that can mean all the difference. Mobile websites and progressive web apps are also a great way to do this. Provide alternatives for the people who are going to be deprecated soon. Eventually, after you've done your best, you're going to have to deprecate old versions of the app because you don't want a mountain of technical debt piling up, either in your code base, on your server, in your deployment strategy, wherever. So provide alternatives like light interfaces. Give users advance warning if you're going to start deprecating an app version. Tell them a few weeks or a month ahead of time so that they can plan for it and so they can continue to use your service even once the app is no longer working for them. Deprecating old app versions is always controversial. Growth, sales, marketing probably have worked very hard to get the people that they have. So you're going to have to align with them to make sure that they're willing to deprecate old versions and potentially lose those people. It's a hard trade-off to make, so make sure you're making it together. Ultimately, you can't support old versions forever. It's too much of a drain on your technical infrastructure and your code base. Users are going to get a worse and worse experience over time. And so ultimately, you do have to deprecate. Let's talk about some of the pitfalls that result in that worse experience. Maybe in version 21, you've got data that looks like this. But what happens by the time you get to version 56? Most of us test upgrading from X to X plus 1 or X to X plus 2. But who here tests upgrading from X to X plus 30? I don't. Wish I did, but I don't. Serialized data survives the upgrade process. And when you see corruption like this, the result tends to be crashes, bugs, and forced logouts, none of which are good for user retention. Your files and persistence will change and evolve over time. Remember how those users in emerging markets tend to be constrained by disk space? After an upgrade, it's a great chance to go clean up old versions, old files, old databases, things that you don't need anymore. It's important to be thoughtful about how you maintain state between upgrades, especially databases and caches. Do you just wipe your cache after every upgrade and refetch everything? That costs a lot of data. Or do you invest in migrating old caches and storage? That can cost more code. So there's a trade-off for you to make based on your business needs. The most important thing to stress here is that if your upgrade path isn't tested often, there's a good chance that it won't work. So take a look at it and see what it's like. You want to be at your best during an upgrade, or you risk your users never upgrading again. Some things to consider that can affect your upgrade rates, notably APK size, and we'll talk about this a little bit more later. Device coverage. Sometimes manifest changes that drop support for devices or require new features on the device or new capabilities or new permissions, that can leave people behind. Permissions, that's a big one. On versions of Android before Marshmallow, new permissions can block auto upgrades, and that's a big deal for your upgrade rate. One piece of advice here is if you do need new permissions, group all of the new permissions that you need into one release so that your users only have to review them once. Now let's talk about reducing APK size. This is one of the biggest levers that you have to improve your upgrade rates. We'll talk about compression and optimization tools, deleting duplicated and unused items, APK splits and dynamic delivery, and downloading assets on demand. For compression and optimization, one of the easiest things that you can do is to enable plugins like Redux or the D8 compiler. It's very straightforward to do. That's almost all the code that's required. It didn't all fit on the slide, but there's a plugin on GitHub that makes Redux easy for your build.gradle file. And D8 is as simple as one line in your Gradle.properties. As always, be sure to test these changes thoroughly and track how your users are faring in production, because both of these systems can produce difficult to reproduce crashes in rare cases. I also recommend using a library like Zopfli to compress your images. Several image crushing libraries exist, and Zopfli is maintained by Google. It does a good job squeezing extra bytes out of your PNGs. If you have 500 bytes that you can save out of 100 images in each of 4 resolutions, that's 200 kilobytes right there. And that can mean a lot for users in emerging markets. Consider compressing your C and C++ libraries. You may have noticed if you have a lot of C and C++ code that it tends to be larger than the equivalent Java code, especially after you run things like Redux or D8. Consider compressing it at build time and then decompressing it at runtime just before you need it, and then storing the result on disk. You can also consider compressing resources.arsc. If you have a lot of languages or special case layouts like landscape, by version, those sorts of things, your resources.arsc can actually get quite large. It tends to compress nicely, though, and you can save a lot of space this way. However, there's always trade-offs that go with compression. You save space in the APK, but it does cost extra CPU time to decompress it, and might also cost extra memory and storage. Next up, to reduce duplicated and unused items in your APK, you've got to know what's in there. And so I recommend unzipping your APK, or just opening it in Android Studio, which has a nice UI for this purpose. So here's a screenshot of the auto-generated starter app from Android Studio. On the right, you have the app itself. It just says Hello World. And on the left, you have the APK open in Android Studio. All I went to was File, Open, and selected the APK. This tells me what's in there. So what do all of these files mean? The res directory holds static assets like images, layouts, those sorts of things. Resources.arsc holds strings and some colors and other resources like that. Inline resources for the most part. All the classes.dex files, that's the Java code compiled down to dex form. And I'm sure you recognized Android manifest.xml. The meta.inf directory is signatures and zip file metadata. So once you have that, start looking for resources and classes and libraries that just aren't familiar to you. Good places to look are in the lib directory, where C and C++ code tends to get stored, under res, where resources get stored, and even inside the DEX files themselves. And Android Studio lets you open those DEX files. Here's an example. Let's look into the layouts directory under res. And I'm sorry, this is kind of small, but what you can see on there is a giant list of things. And remember, this is the basic Hello World sample app that was generated by Android Studio. Why on earth do we need all of those layouts? I guarantee you we need exactly one, and that's a lot more than one. So this is an example of lots of stuff that you can get rid of. Also look for things that are duplicated. This can come in the form of code. You might have duplicated C and C++ libraries. It could be images, it could be videos, it could be sound files, you name it. When things are duplicated, that's a great opportunity to save space at zero cost. Next up, you have to track down the dependencies that include those items. This can be a bit tricky to figure out what exactly is bringing something in. But usually, it boils down, when you have duplicated items, it boils down to two things, both needing a version of a dependency, and they're not talking to each other. When you have unused files, it means that sometimes you just have to go through your dependencies one by one until you find what's pulling it in, if you can't guess based on the names. And I'll leave this as an exercise to all of you. How many copies of OpenSSL or FFmpeg do you think you're shipping in your apps? Do you feel comfortable checking that? Another great strategy for reducing APK size is APK splits and dynamic delivery. You can ship different APKs for different resolutions. And this can make a huge difference, because all of those assets that we like to ship for XXHDPI, they still live on all the MDPI devices, but they're never going to be used. That's a lot of extra space that's just being wasted. This is really easy to do. You can do it in your build.gradle with code that looks almost like that. The same holds true for ARMv7 versus x86 CPUs. If you don't have much C and C++ code, this might not make such a big difference. But if you do, and maybe it's worth checking if you do, this can double the amount of C and C++ code you're shipping, which tends to be large to begin with. This is also supported by default in build.gradle. You can even combine splits and ship versions that are cut both by ABI for the CPU and also screen density. Another recommendation is to use dynamic delivery to ship infrequently used features separately from the main APK. This is great for features that aren't often used, but end up requiring a lot of code and data. You can have a small main APK that's easy to upgrade. And then the people who really want that feature, who probably are going to be more invested in your app to begin with and more likely to be upgrading constantly, they can download that feature separately. This is also supported in build.gradle, but the code's a little bit too long to show on a single slide, so you can find it online. Another step here is to download assets on demand that aren't immediately needed in your app. Those assets that are infrequently used, like not splash screens, but full screen interstitials, you can download them later and save users the trouble of having to download them from the Play Store. There's a trade-off here, of course. It costs a little bit more in server load, and you might have to wait a little bit while those images download. But it can cut out a lot of APK size. Trade-off's up to you. Consider downloading images, fonts, videos, and sounds, and even other static files if you have data files that you need. Virtually all assets can be downloaded if you want. For images, I recommend Fresco, but there's lots of other libraries out there as well. Support library v26 even supports downloading fonts on demand. So key takeaways, to sum things up. Plan your deprecation and upgrade strategy early. If you want to be able to use a deprecation strategy in a year from now, you have to set it up now so that people upgrade to the version that has the deprecation feature. Invest in future-proof technologies that can help support users over time, even when they're on older versions. Keep your APK size small and build light interfaces for users in emerging markets who can't stay up to date on a full-size app. And don't forget about the users in emerging markets who really want to use your app, but just take longer to upgrade. Thank you all for listening. I'd love to hear more from all of you, so please come ask questions. What do you do for app upgrades? What are the pitfalls you've run into? How do you keep your APK small? And how do you support users on older versions? Thanks.